Namaste to everyone. Today in this session, we are going to discuss some numerical problems from the lesson Motion. Let us start. Here we have the first question. If the displacement of an object is proportional to square of time, then the object moves with. The options are given as option A, uniform velocity, option B, uniform acceleration, option C, increasing acceleration, option D, decreasing acceleration. Actually, we have the formula for displacement and time relation. We have this formula S is equal to ut plus half at square. Anywhere else we don't have any formula which is showing the relation between these two. So let us write this formula. S is equal to ut plus half at square. In this one, this formula we are going to write whenever we have uniform acceleration. We have seen already that these three formulas, whatever we have, V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. These three formulas we will use whenever there is a uniform acceleration. So we can select this option B. Here you can see displacement is directly proportional to square of time. If you are having initial velocity is 0, then we can write S is equal to 0 into t. So it will become 0. We can write S is equal to half at square. So when you are writing S is equal to half at square, what happens here? If you are taking acceleration is uniform, then S will become directly proportional to t square. So we got the same statement what is given in the question. So we can select this B option. Going to second question. Here some graph is given. This is a graph between velocity and time. Now based on this graph we have this question. From the given VT graph, it can be inferred that the object is. From this graph what we can understand? The object is in uniform velocity. Velocity is not changing according to the time. So here the options are given. Option A, at rest. It will not happen because object is moving there. Velocity value is there here. Option B, uniform motion. Yes. Option C, moving with uniform acceleration. Here acceleration is not there. V value is same from starting to ending. Sometimes you can say that acceleration also uniform because acceleration every time it is 0. But option B is there, uniform motion. So let us select B option. We'll say D option also. It is showing that it is in non-uniform motion. This is wrong. So we can select here B option. Object is in uniform motion. Coming to third question. Suppose a boy is enjoying a ride on a merry-go-round which is moving with a constant speed of 10 meters per second. It implies that the boy is. Here merry-go-round means it is circular motion. If the boy is moving with constant speed 10 meters per second, we can't say that he is moving with constant velocity. Every time the direction is changing, so velocity also changes. The change in direction is similar every time, so we can say that the boy is moving with uniform acceleration. Change in direction is same, that means change in velocity is same. Change in velocity per unit time is nothing but acceleration. So here let us see the options first. Option A, at rest, no. Option B, moving with no acceleration. No, acceleration is there because he is not moving with constant velocity. Change in velocity is there. Then option C, in accelerated motion. Yes. Then option D, moving with uniform velocity. Uniform velocity is not there. Accelerated motion is there. And if we say that this is uniform circular motion, constant speed, we can say this as uniform acceleration also. So here we are selecting the option C. Coming to fourth question. Here one more graph is given, one more diagram is given, circular motion from the center to the end of this circle, which is known as the radius. R value is given, the origin is given as O. So here radius is R for this circle. Now let us see what is the question given. Question number 4. A particle is moving in a circular path of radius R. The displacement after half a circle would be. Here the object is moving. Let us take the starting point as A. From A it has moved up to B. From A it has moved up to B. Then what happens here? It has taken the distance of half of the perimeter, but displacement they are asking here. So R plus R, 2R it will become. Now let us see the options what are given. Option A 0. No, it is not 0. From A to B it is moving. When it will become 0? When the starting point is equal to the ending point. Then we can take 0. But here it is not that case. Coming to B option, pi R. No. Then C option 2R. Yes, it is correct. R plus R. Then D option is given 2 pi R. This is also not correct. If they have given distance, then what we can select? We can select pi R, because we have to take the half of the perimeter of the circle. So pi R we will select when they are giving distance question. As they have given displacement, just R plus R, shortest distance traveled by the object we have to take here. So starting to ending we have drawn one straight line. So that straight line length is 2R here. So we are going to select C option. Fifth question. Which of the following can sometimes be 0 for a moving body? What will be 0 for a moving body? Average velocity, distance traveled, average speed, displacement. Which will become 0 for a moving body? Already the body is moving. So distance traveled will not be 0. Average speed also will not be 0. But displacement may be 0. If it is started from one particular point and it has reached the same point after moving some distance, then if displacement is becoming 0, average velocity also will become 0, because velocity is nothing but displacement by time. 0 by time we will get 0 only. Now let us see what are the options given. Only 1. Option B 1 and 2. Option C 1 and 4. Option D only 4. So here we can select option C. Displacement, if it is becoming 0, average velocity also will become 0. Going to sixth question. Which of the following statement is correct regarding velocity and speed of a moving body? Option A, velocity of a moving body is always higher than its speed. It can't be like that, because speed will be greater than velocity. We have to compare displacement and distance. Distance can be greater than displacement, or it may be equal, but never distance is less. So speed also will not become less compared to the velocity. Option A is not correct. Option B, speed of a moving body is always higher than its velocity. Always higher, that is not correct. Sometimes may be equal also, no? Then option C, speed of a moving body is its velocity in a given direction. No. Velocity in a given direction we are not taking here. Reverse we have to take, like which is there in D option. Velocity of a moving body is It's a speed in a given direction. If the speed is having some particular direction, then we can define that in the form of velocity. Coming to 7th question. When a car driver is traveling at a speed of 10 meters per second, applies the brakes and brings the car to rest in 20 seconds, then the retardation will be, here starting means initial velocity is given 10 meters per second, u value, and final velocity is given 0, applies brakes and brings the car to rest. Means we can say v is equal to 0 here, and u value is 10 meters per second. Then time is given here, t value 20 seconds. We have to find out what is the retardation. Now let us calculate. After that we'll see the options. A is equal to v minus u by t. A is equal to v minus u by t according to the formula of acceleration, that is equal to 0 minus 10 divided by 20. Here we are going to get minus 10 by 20, that is nothing but minus 1 by 2 or minus 0.5. Let us see what are the options given. It may be given as minus 1 by 2 or it may be given as minus 0.5. So let us see what are the options given. Option A is given here as plus 2 meters per second square. No. Minus 2 meters per second square. No. C option, minus 0.5 meters per second square. Yes, this is correct. D option is given as plus 0.5 meters per second square. Retardation means compulsory it will be negative acceleration. So we are going to select the C option. Sometimes in hurry, many of the students will write 1 by 2 as equal to 2. So this should not happen, children. So minus 1 by 2 is the answer here. The option may be given as minus 1 by 2. In one option minus 0.5, another option minus 1 by 2, and one option may be given as both. So both will be correct. So you check the options what are given. But whenever these numerical problems are given, better you calculate first. After that you see the options. Otherwise in hurry you may be selecting some other wrong option. Now we'll see about 8th question. Here one more graph is given, children. Here this is a graph between speed and time. Speed and time graph is given here. Here initial velocity is given 5 meters per second. Final velocity is given 30 meters per second. 30 meters per second. Starting time 0, ending time here 50 seconds. 50 seconds. Now let us see what are the question and options here. The speed time graph of a car is given here. Using data given in the graph, calculate the total distance covered by the car. Total distance we have to calculate here. We can take whatever this area is given, whatever the polygon is given here, the area we can find out directly. Otherwise we can take the formula and we can do in that manner also. Two methods are there, you have learnt already. So once we'll see the options here. Before seeing the options, better you will calculate that, and after that we'll go to that options and all. So here we have the formula S is equal to ut plus half at square. Otherwise we can go for v square minus u square by 2a. So we have to find out a value first before finding out s value. A is equal to v minus u by t. V minus u by t. V value we have here 30, and u value we have here 5, and time is given as 50. 30 minus 5, 25 by 50 means 1 by 2. 1 by 2 meters per second square is the value of A. Then we have to substitute this in this formula. Either we can go for the second equation or third equation. Whichever is easy, that you can use. V square minus u square by 2a. I am using this. So V square value is nothing but 30 square. 30 square means 900. 900. I'll continue this calculation down. 900 900 minus u square value. What is u square here? U square means 5 square. 25. 900 minus 25. 900 minus 25 divided by the acceleration we have to take 2 multiplied by acceleration 2 into 1 by 2. 2 into 1 by 2 means anyway 1 we can take. 900 minus 25. 900 minus 25 means here we are going to take 875. Let us see this option is given or not. 875 meters. Option A is given 1250 meters. Option B is given 875. Option C is given 1500 meters. Option D is given 870 meters. So our answer is here 875. Instead of this, you can find in this manner also area of this trapezium. Area of the trapezium also you can take, and from that also you can find out. Whichever is easy, that particular thing you can follow. Coming to 9th question, children. A car of mass 1000 kg is moving with a velocity of 10 meters per second. If the velocity time graph for this car is a horizontal line parallel to the time axis, velocity time graph, horizontal line parallel to the time axis, then the velocity of the car at the end of 25 seconds will be option A 40 meters per second, option B 25 meters per second, option C 10 meters per second, option D we have here 250 meters per second. Here horizontal line they are giving, that means velocity is constant starting to ending. So we can take the same value what is given in the question, 10 meters per second. Going to 10th question. Which of the following is most likely not a case of uniform circular motion? Not likely the case of. Let us see the options. Option A, motion of the earth around the sun. Motion of a toy train on a circular track. Option C, motion of a racing car on a circular track. Option D, motion of hour's hand on the dial of a clock. Most likely not a case of uniform circular motion. Toy train may not have the same speed from starting to ending. Here they are saying that uniform circular motion, starting to ending it should have the same speed. Toy train, racing car. Yeah, which one we can select here? Racing car. Racing car may not have the same speed starting to ending, it will not have the same speed. Now toy train will have starting to ending, with same speed it will move, it is not going to change. So we can select here C option. Okay, some more problems we'll discuss in the next session. Practice these 10 questions, children.